Today I'll talk about economic order quantity. I will describe two approaches to calculate the economic order quantity. This is part of my series of lectures on operations management and supply chain management. So the ordered quantity, there are various approaches. One is lot for lot. The ordered quantity, what is needed is no more, no less, and this approach, lot for lot, is used in just-in-time manufacturing environment, and it is best for category A items. The next is fixed order quantity. Here, uh, we specify the number of units to be ordered each time an order is placed for an individual item or stock keeping unit. Then is a fixed time system or periodic review system. So rather than ordering a fixed quantity, inventory management can order enough to satisfy future demand for a given period of time. Here we order up to a target level and it is known as order up to the target level. Then there is economic order quantity approach, and it is applicable for both the replenishment policies as order point and order period policies. So first approach of calculating economic order quantity is balancing the carrying cost and ordering cost. So the assumption in this approach is that the demand is relatively constant and is known. The item is produced or purchased in lots or batches and not continuously. Order preparation cost and inventory carrying cost are constant and known. Replacement occurs all at once. So if A is the annual usage of item in units, Q is order quantity in units, S is ordering cost per order, C is unit cost in dollars, and I is annual carrying cost rate as a fraction. So this is important that I is in the form of fraction. So annual ordering cost is this, annual carrying cost is this. So total annual cost is the combination of annual ordering cost and annual carrying cost. This is the graph I have taken from a particular textbook. So this is the actually ordering cost. If we order small quantities multiple times, so ordering cost is more as compared to a larger quantity with few orders. This is the carrying cost. So if we order small amounts, we have less inventory, average inventory. So we have less carrying cost, and this increases with the increase in lot size. So at the crossover of these two graphs, the total cost is lowest. So it is the lowest point of this total cost curve. So equate both the ordering cost and carrying cost. So if we equate both, we can estimate the economic order quantity in physical units as this and economic order quantity in monetary units as this. For a period order system or a replenishment policy, when we actually the order period method is there, then the EOQ is divided by average weekly usage, and we can order like that. So, what are the practical considerations when using economic order quantity as calculated from the ordering cost and carrying cost? So, if demand is lumpy, then EOQ assumes that demand is uniform and the demand is lumpy. So, the EOQ will not produce the best result when demand is lumpy. It is better to use the period order quantity method. So, anticipation inventory, when demand is not uniform and stock must be built ahead. It is better to plan a built-up of inventory based on capacity and future demand and not on the basis of EOQ calculation. Third consideration is minimum order. So some suppliers require a minimum order. So this minimum may be based on total order rather than on individual items. Often these are C items where the rule is to order plenty and not on the basis of economic order quantity. Transportation inventory. So carriers give rate based uh, on the amount shipped. A full load costs less per ton to ship than a part load. So then multiples. Sometimes order size is constrained by package size. For example, a supplier may ship only in skid load lots. In these cases, the unit used should be minimum package size, not an individual item. Then order quantities and just-in-time manufacturing. It has a profound effect on the amount of inventory to be produced at one time. The replenishment quantity of an item is adjusted to match the demand of the next operation in the supply chain. Now, the second approach to calculate economic order quantity is balancing the inventory surplus and inventory shortage. So let us say that if CL is cost due to leftover inventory when there is inventory surplus. So inventory surplus is there when probability of demand, that is market demand, is less than the ordered quantity. So we are left with inventory. So it can be written in a symbolic form as probability such that D is less than OQ or ordered quantity. This is inventory shortage condition situation. So CS is caused due to inventory shortage. So inventory shortage is when the actual demand is more than the ordered quantity. So it can be written symbolically as these. And if we balance these two scenarios, we equate these two costs actually. So we multiply CL by the probability of this situation surplus and CS by probability of shortage situation. And when we rearrange, we can just derive the ordered quantity, critical level ordered quantity as CL divided by summation of CL and CS. And if we denote this entity as alpha, so alpha is nothing but stock out level because demand is more than ordered quantity. So it is a stock out situation. So if we subtract this alpha from 1, that is, we calculate 1 minus alpha, it will be the service level. So the formula for economic order quantity is demand plus, this is the average demand, plus inverse of cumulative density function of standard normal distribution at the service level 1 minus alpha, which we have calculated previously from this entity, multiplied by standard deviation of demand. So this is another approach or second approach to calculate the economic order quantity. This is all for today. Thank you very much.